Hi everyone, in this video we are going to solve this double integration. Okay, so let us write the integration first. I is equal to what they have given, double integration over S x square plus y square dx dy. So region S, it is in xy plane which is bounded by these four different curves. So they have added one condition. That condition is we have to solve this double integration by suitable change of variables. That means we have to put something, we have to convert a problem into some different variables and then we have to solve. So let us write first, okay, the region is bounded by, so S is bounded by, so what have they given, x square minus y square is equal to 1, x square minus y square is equal to 2, xy is equal to 2 and xy is equal to 4. So x square minus y square is equal to 1, x square minus y square is equal to 2. These are equations of hyperbolas, right? And these two are rectangular hyperbolas. So that means region will be so much complicated in xy plane. So obviously there is a need to substitute something to make the problem more simple, okay? So I am going to do the same. See, by observing all these four equations, we can easily see there is some pattern. What is that pattern? X square minus y square, here is also x square minus y square. So I will select the same thing for my substitution. So I am going to put x square minus y square is equal to u. So let me mention putting x square minus y square is equal to u. And here xy is equal to 2 and xy is equal to 4. That means xy is repeating there. So that's why I am going to put xy is equal to v. Okay. So whenever in double integration we put something, it's so much necessary to find a value of Jacobian. So now the question is, what is Jacobian? So Jacobian is one determinant dabba x by dabba u, dabba x by dabba v, dabba y by dabba u and dabba y by dabba v. That means derivative of x and y with respect to u and v we supposed to calculate. But it's quite difficult task because for that thing, we need to express x and y in terms of u and v. Right now, we have u and v, okay, in terms of x and y, okay. So that's why it's very difficult task to find the values of all these derivatives and finally Jacobian. But see, there is solution on that. There is one more method. We can calculate z dash, which is comparatively easy. Since the formula of z dash is dabba u by dabba x, dabba u by dabba y, dabba v by dabba x and dabba v by dabba y. It's comparatively easy. Oh, you can easily see the difference here. We find derivative of x and y with respect to u and v, and here we find derivative of u and v with respect to x and y. U and v are already expressed in terms of x and y, so we can easily find the derivative. So I will follow the second method. I will find z dash, and z is nothing but reciprocal of z dash. By simply taking reciprocal, we will get the value of z, Jacobian, okay. So let us calculate z dash. Let me remove this one and let us start to find, okay. Just a minute. Okay, that's it. See, then let me write a formula. Z dash is equal to dabba u by dabba x, dabba u by dabba y, dabba v by dabba x, dabba v by dabba y. So let us do some rough work to find all these partial derivatives. Okay, so we can solve directly also. So derivative of u with respect to x, let us find. So where is my u? This one. It's a derivative with respect to x. So x square minus y square. So you know that whenever we have plus or minus sign, we take separate derivatives. So derivative of x square is 2x and derivative of y square. Y is constant here since we are finding derivative with respect to x. So its derivative will be 0 and we will have 2x. Derivative of u with respect to y. So we are going to find derivative of same function with respect to y, okay. Subtraction is there, we can take separate derivatives. Derivative of x square is 0. Since it is constant, we are differentiating with respect to y, minus derivative of y square is 2y. So the answer is minus 2y. Now derivative of v with respect to x, its derivative, okay, its derivative with respect to x. So what is our v? xy. See, y's constant will come outside, okay, and derivative of x is 1, so the answer is y. Derivative of v with respect to y. So we are differentiating with respect to y, so that's why x is constant this time, it will come outside, and derivative of y is 1, so its value is x. So in this way I got all 4 derivatives, so it's easy to calculate z dash. Let us put the values. Its value is 2x, value of this one is minus 2y, value of this one is y, and value of this one is x. Let us solve determinant. You know that how to find a value of determinant. Product of these two, which is 2x square, minus product of these two terms, which is minus 2y square. Minus minus plus 2x square plus 2y square. Definitely we can take 2 common. So x square plus y square. So this is value of z dash. Okay, so actually our target is to find z, Jacobian. But see, z is reciprocal of this, so let us find it. Just make a screenshot of it, then we will go further. So then our z will be, Jacobian z is reciprocal of z dash. So it's reciprocal, that means 1 upon 2 x square plus y square. So in UV plane, okay, so we are talking about UV plane now, since we have to find the limits of integration. Okay, so in UV plane, region is bounded by, so we can easily write using these 4 equations. So x square minus y square is our u, so that's why u is equal to 1. This is our u, so u is equal to 2. Second equation we got. This is our v, so v is equal to 2, next equation, and last, this is our v, so v is equal to 4. So in this way we got 4 lines basically, these are lines, getting? And in UV plane, region is bounded by these 4 simple lines. So let me draw a rough sketch here, okay? Rough sketch I will draw here. So this is v axis and this is u axis, right? This is 1, 2, 3, 4. 1, 2, 3, 4. So u is equal to 1, it's a line parallel to v axis, passes through u is equal to 1. This is a line parallel to v axis, passes through u is equal to 1. U is equal to 2 will be here, parallel to v axis, passes through u is equal to 2. V is equal to 2 will be here, right? And v is equal to 4, line parallel to u axis, passes through v is equal to 4. Let me show here, this is v is equal to 4. I hope it is visible. V is equal to 2. This is u is equal to 1 and this is u is equal to 2. So this is region of integration, getting? This is region of integration, and here I will consider a strip parallel to v axis. So let me write a limits here. Our strip is parallel to v axis, so I should write limits of v first and then limits of v, u. So you know that in case of double integration, when we draw a strip, we have a very basic funda. Strip is bounded below, bounded above, and we move strip from left to right. Strip is bounded below by v is equal to 2. It is bounded above by v is equal to 4. Okay, it start at u is equal to 1. Strip moves like this, getting? Strip moves like this. It will start at u is equal to 1 and it will go up to u is equal to 2. So finally we got limits. Okay, so let us start to solve integration. Okay, so let us do it here. What is the integration we have? Let me write I is equal to, this is our integration, x square plus y square over s dx dy. Actually it is in dx dy, but now with the help of that substitution, we have converted a problem in UV plane. So I should write everything in terms of u and v now. So as you can see here, the limits of v 2 to 4 and limits of u 1 to 2, getting? So here x square plus y square, I supposed to convert it into u in terms of u and v, but see, it's very difficult task since x square minus y square is our u and xy is v. So right now I will keep as it is. Okay, so let me write as it is, x square plus y square. Actually we supposed to express in terms of u and v, but we know there is some relation between them. So I supposed to write z here and du dv. Since dx dy is nothing but z du dv. Okay. This is equal to integration 1 to 2 integration 2 to 4 x square plus y square. What is our z? Our z, yeah, this one upon 2 x square plus y square du dv. Okay, so j is also in terms of x and y. So you can easily see here we can cancel out this bracket x square plus y square. That 1 by 2 is constant. Sorry, I supposed to write dv du here. Since our strip is parallel to v axis. Here I should write dv and here I should write du. Okay, so let us solve. 1 by 2 is constant, it will come outside 1 to 2. So only dv is left there. Getting all functions I have cancelled, 1 by 2 is constant came outside. So only dv is there and we have to write its integration. Integration of dv is v 2 to 4 du. Okay, so let us use this space. I will write here. So 1 by 2 integration 1 to 2. I am putting upper limit 4, lower limit 2 du. So 4 minus 2 is 2 and that cancel with this 2. So integration 1 to 2 du, its integration is u with limits 1 to 2. I am putting upper and lower limit. So 2 minus 1 which is 1. This is required answer. Okay. So make a screenshot of it, then we will stop. Thank you. See you.